SolidWorks is based on a few technologies that are shared by many major mechanical CAD systems. SolidWorks represents 3D objects in the boundary representation structure. That is the most common way in modern CAD systems. Dimension-driven system is closely related to the parametric system. The shape of the model is defined by parameters, and the values of the parameters can be changed, which drives the changes of the geometries of the model. In many cases, the shapes are represented by dimensions. By changing the dimensions, the shapes of the size of the model can be altered in a controlled way. Here's an example of a box, and its size is defined by the width, length, and height dimensions. By changing the dimensions, the size and shape of the box can be changed. Many modeling characteristics such as part geometry, relative positions of components in an assembly, can be constrained by dimensions and geometric constraints, such as coincidence and concentricity. In this example, the designer's intention is to have the three holes spaced equally on the top surface of the bracket. Regardless of the length of the bracket, the intent is represented as an equation, and by changing the parameters, the model changes satisfying the user's intent, in this case, the spacing of the holes. A feature is a building block in creating a model. Complex models are built by keep adding features on top of another. This will make a list of features. Features are added in the order of the feature tree. So this list represents the history of the model and their parent-child relationships. For example, the cylindrical boss cannot be made before the base block is made. So the boss is a child of the base block. Using the parent-child relationships, the system knows which features needs to be updated when a certain feature changes, so the model is updated automatically. The features in the feature list can be reordered by the user, but there's a restriction that certain features cannot be relocated before their parent features. Because the model geometry is made by the order of the features, and the order is maintained and managed, the system is called history-based system. The final model geometry depends on the order of the features. Even if the feature set is the same, the final geometry may be radically different if the orders are different. The design intents are represented by the features, constraints on dimensions, and geometry relationship, among others. In this example, the intent of the model is to make the hole at the center of the block, and the top slot should run through the top surface. If the model size or shape changes, the intent should be maintained. Incorrect use of features may result in a wrong model. The product design is an iterative process. The model will constantly change, but the model should maintain important design intents. CAD is a design tool, and it should be able to represent many what-if scenarios. Even for one part, designers may want to make various versions of shapes. If a separate file needs to be created for each different variations, maintaining such many files will be a nightmare. In SolidWorks, each document can have many different configurations, and it can be created and managed by a design table. There are basically three different document types in SolidWorks. A component is designed in a part document, and an assembly is made by combining multiple components. Drawings are made by projecting the parts or assemblies. When you create a model, you need to select the proper type of document. There are two ways of building a product model. In the bottom-up approach, each component is first built, and then an assembly is made by combining the components. In the top-down approach, the components are created inside an assembly. Usually, a hybrid method is used where the initial design starts with an assembly and create components in the assembly, but some components are also made as a part and inserted into the assembly. An assembly can also contain another assembly that is a subassembly that also can contain another subassembly, forming a hierarchy. The three documents are dependent on each other, meaning that a change of one document propagates to other documents and update it. This example demonstrates how easy it is to change the model, and the change can be propagated to the assembly and the drawing. the change is multidirectional. So any changes in assembly or a drawing also propagate to other documents.